Okay, we're going to try to show you how to use a graphing calculator to graph some equations. What I have here is I have this absolute value here, and I've typed that in to this side of my equation. And then I have the other side of the equation, 4x minus 3. I'm going to type that into Desmos as well. So I can type in the 4x minus 3, and I get those two equations, the absolute value on one side, the linear equation on the other side. Notice the absolute value is in red. It is a V-shaped graph. The 4x minus 3 doesn't have an absolute value, so it's a linear graph. What I'm looking for the solution is the point where they intersect, which is marked by a gray dot. Now, it's your job. Desmos knows the gray dots are important and shows them to you. It's your job to know which one you actually want. So in this case, we want the intersection where the red and the blue, the two different graphs, touch. Now, the intersection here is 1.67. You might get suspicious that 1.67 might have been a repeating 6, and it was. In this case, unfortunately, Desmos on the graph only gives you a rounded decimal, but that should be good enough for you to check any answer you have. I'd take it as an answer to a short answer assessment, or if you have multiple choice, you would see 7/6. And how you would know that 1.167 is the same as 7/6 is you could just simply try in Desmos an answer choice of 7/6 and see that gave you the 1.167, or at least something that you would round to that. Now, on the other side, you notice I have a similar equation. The left side is exactly the same, but in this case, the right side has changed because it has an absolute value in it. So you might say, well, Mr. Hess, that's about the same equation. Well, it is, but about does not mean the same, because when I put this absolute values on, you notice now that becomes a V shape, and by bouncing back around, it does touch it twice. So I still have the same solution I did have of the 7/6, or the 1.167, but I also have a second intersection of negative 0.5. And if you wanted to list that as just negative 0.5, that would be okay, but that is the same thing as negative 1/2. And once again, fractions are preferred to rounded decimals in this class. So better fractions than rounded decimals. But in this case, you had two solutions. In the other case, you only had one. There is no easy way to see, especially once you have variables on the other side, to see if there's going to be one or two solutions. But you can always use your graphing calculator and find out. That variable on the other side often makes an extraneous solution if you were to solve it algebraically. So that is a very useful tool to use your calculator to check for these. One other thing I do want to mention is if I have just a plain function, for example, like one of the ones we were doing at the top of the page, just a x plus 4 equals 2. We'll try that. Let me change that absolute value to an x plus 4. Notice I didn't delete the absolute value. I just edited what was in it. Saves me a few keystrokes. If I try typing a 2, it will not give me anything. But if I put a y equals in front of it, if you have a plain number like that 2, where the graphing the left side was easy, the right side was just a 2, sticking a y equals in front it lets Desmos know basically that you're trying to graph something instead of just type in the number 2 or part of an expression. And then I have, those are my solutions. So my solutions are negative 6 and negative 2. Once again, I do not need to use the y coordinate. I can just have negative 6, negative 2, like I think we had already figured out algebraically, because since the equation only has an x, the y doesn't matter. I only need my x coordinates. So negative 6, negative 2 would be my answer, or sometimes you might see it written as x equals negative 6 or negative 2. I hope this shows you how you can use Desmos to solve absolute value equations. You can actually use it to check your solution to any kind of equation, but those harder absolute value equations, it's very handy.